LeetCode is an online platform that provides many different coding challenges where you can improve your coding skills and prepare for technical interviews. And in a previous video, I recommended doing these challenges as one of the steps to help you transition from a beginner to intermediate programmer. So today, we're going to go through 3 challenges from the top interview questions list and break them down step by step. So we're going to jump over to the top interview questions and choose 3 beginner challenges for this tutorial. The first one I've picked is a challenge called reverse string. Now this has been categorized as easy, but a better indication of the difficulty level can be estimated by the acceptance rate. The acceptance rate gives us the percentage of users who have successfully solved this problem. And we can use this as a rough gauge to show us how difficult we may find this problem compared to others in this easy category. Okay, now let's have a closer look at this question. It says, write a function that reverses a string. The input string is given as an array of characters represented by the variable s. And it also says, you must do this by modifying the input array in place with constant space complexity. We'll get into the meaning behind this in a minute. Now, without this second part to the question, this problem would be easy to solve in Python. We could simply use Python's slice notation, where we could take our list variable s and type in this onto the end. When we use this for our list or any other sequence, it generates a brand new sequence, but in reverse order. So what's wrong with this solution? Well, it doesn't abide by the second part of the question. It says we must modify our input string in place with a constant space of extra memory, and they provide a helpful link to Wikipedia to explain what this means. But to summarize, an in-place algorithm will operate directly on our string inputs without needing to set aside additional memory that grows in size in proportion to the input size. The big O notation here represents constant space, which means that the algorithm we're going to write to reverse our string must take up a fixed amount of memory, no matter what size our input is. String slicing doesn't allow us to achieve this because it makes a copy of the original list before reversing its contents, and this copy is totally dependent on the size of the original list. So if our list grows in size, then our copy of our list will grow in size. Luckily for Python 3, there is a built-in function in the standard library that does inline reversal, which I'll show you in a second. But if we were writing our code in C, it might look something like this. The first line is creating a pointer, and a pointer is a variable that holds a memory address. And the pointer we have here is storing the memory address of the last element of the input string. Next, this algorithm checks if the input string is either empty or only has one character. If this is the case, nothing needs to be done because you cannot reverse a single character. Now we're obtaining the first character in the input string and storing it in a temporary variable. We then obtain the contents of the last element in the input string and move it to the first element location. The next line takes our temporary value, which was originally the first element in the string, and then plonks it at the end of the string. Finally, we recursively call our function from the inside with the goal of swapping over the next elements within the string and finishing when we reach the center. In Python, we can do this in one line using the reverse method. And if we go to the Python documentation, we can see that this will reverse the elements of the list in place. Okay, now we're going to move on to challenge 2. This is also from the list of top interview questions and is arguably a bit tougher due to its slightly lower acceptance rate of 70%. Our question is asking us, given an integer of size n, where n can be any whole number between 1 and 10,000, return a list of numbered strings from 1 to n where we replace our index with fizzbuzz if it's divisible by 3 and 5, fizz if it's divisible by 3, and buzz if divisible by 5. And we have some examples below to clarify this. So what do we need to do here to achieve this output? First, let's create an empty list that will store our final result. We can populate this list as we cycle through all numbers from 1 to n. To cycle through any number range of unknown size, we need to set up a loop of some kind. Python supports two types of loop, a for loop and a while loop. A while loop will execute a block of code until a specific condition is false. A for loop, on the other hand, will iterate over a sequence of some kind until it reaches the end of that sequence, or if it hits a break command. Now we could use either loop for this challenge, but because the challenge doesn't give us any reason why we might want to break out of our algorithm, it doesn't make sense to use a while loop with a condition. We would simply need to write extra code to set this up. Instead, it's easier to use a for loop and the range function to generate a sequence of numbers from 1 to n plus 1. Now we've put the plus 1 on the end here because the range function will generate a sequence of numbers from the start number up to, but not including, the end number. Our num variable here will store the next sequence in the list upon every iteration, and we must now check if this value is a multiple of 3, 5, or 3 and 5. To see if we have a multiple of 3 and 5, we can use the lowest common denominator or lowest common multiple of 3 and 5. This is basically the smallest number that each of our given numbers can evenly divide into. So now we can write an if statement that will check if our num variable divides evenly into 15 without leaving a remainder, and we use the modulus operator to do this. We can write two further if statements that will check for 3 and 5 separately and append the appropriate word in our list. For all other numbers that don't divide evenly into any of these numbers, we simply convert our num variable into a string and append this to our list. After we've gone through every number, we return our list. So the last challenge here requires a bit more thought than the previous two. And we're going to use the hint at the top here to help us out a bit. But first, let's see what the question wants us to do. So it's giving us the rules of how Roman numerals are converted into integers, and we have 7 unique symbols here representing these corresponding values. It also tells us that in most cases, Roman numerals are written largest to smallest, from left to right. But in some circumstances, this rule is broken. For example, 4 is written as IV instead of having 4 I's, and it shows us other various situations where a smaller symbol will come before a larger one, like in the case of 4 and 9, or 40 and 90, and so on. So given this information, how can we convert a Roman numeral, like this, into an actual number? So let's try this quickly with an example. V equals 5, so we can add that to our running total. Because our next symbol is smaller than our first symbol, we must subtract its value from the running total. So we have 5 minus 1, which equals 4. Now we store 4 in our running total. The third symbol along has a greater value than our previous symbol, so we now add this value to our running total. So 4 plus 100 equals 104. We continue this process until we reach the first symbol in our list, and our running total will now contain the integer representation of the Roman numeral. First, we must reverse our input string with Python's reversed function, and then convert it into a list data type. We extract the first element of our reversed list and find its value pair within our dictionary using the get method. We store this integer in a variable called previous value, and then we add this value to our running total, represented by our answer variable. Now we use a for loop to cycle through the rest of the symbols, then obtain the current element's value from our dictionary, and then add this current value to our running total if it's more than or equal to the previous value, or decrement it if the value is smaller. We then set the new previous value to the current value before cycling through the next for loop. Once complete, a running total in the answer variable can be returned from the function call. Okay, that's it for today. Now these challenges can be daunting when you're new to programming, but if you keep practicing, they will get a lot easier. I also recommend you check out other people's solutions in the Solutions tab, because with this many solutions, you will always find solutions that are more eloquent than yours, and you'll learn a lot from them. Anyway, I hope this helped today, and do post any questions you have in the comments below, and I'll get back to you as soon as I can. Take care, and I'll see you soon.